The next section in Unit 9 regarding the Pythagorean Theorem is Section 2, and we will be working with application-based problems. So we'll be taking what we know about the Pythagorean Theorem and using it in real world and other mathematical problems in 2 dimensions. So again, in review, you don't need to write this down, but the Pythagorean Theorem states that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. Remember that the hypotenuse is always the longest side of the triangle. So here we have an example where we have a diagram of a pond in Paul's neighborhood, and it's shown here below in the lower right-hand corner. He notices that the shape of the pond is somewhat like a triangle. He claims that he can approximate the perimeter of the pond without doing any additional measuring of the actual pond or the diagram. So what assumption does he need to make in order to justify this claim? And the idea here is that the assumption he's making is that this pond is shaped like a right triangle. And that's what we would write. The assumption is that the pond is shaped like a right triangle. And it seems like almost every single year they have a question where there's some sort of situation, and then the assumption that's being made in order to find a certain length of something, the assumption is that it's a right triangle. So based on the assumption, what is the perimeter? Well, in order to find the perimeter, we need to know this side length over here. Now obviously this pond is irregularly shaped, but if we were to draw a straight line, whoops, missed, from one corner to the other, we're trying to find that side length. And you'll notice that if we draw this like a right triangle, that's the hypotenuse. So we're going to set up the Pythagorean theorem. A squared plus b squared equals c squared. I'm going to label 80 as side A and 125 as side B. So that's 80 squared plus 125 squared equals c squared. And again, get your calculator if you need to. 80 squared is 6,400. 125 squared is a humongous number, 15,625. And we don't know the hypotenuse. And we add those two numbers together, you get 22,025. We have to square root both sides, remember, to find what c equals. So c equals the square root of 22,025. And that's going to give us a decimal, 148.408. So let's, in this case, since we are really just kind of making assumptions or an approximation, let's just round that to 148. Let's keep it with a whole number. You could do 148.4. You could say, I would either say 148 or 148.4, but I'm going to keep it just with whole numbers. Again, it doesn't tell us what to round to, so we'll say 148 yards. But it did ask for the perimeter. Remember, the perimeter is the distance all the way around the triangle. And I've run out of room here, so the perimeter comes from 80 plus 125 plus 148. And remember that this is all in yards, so you will want to make sure you have a unit here. So 80 plus 125 plus 148. That's about 353 yards. So there's a real-world type problem, application-based problem of the Pythagorean theorem. Next example, it says, after school, Kevin skateboards directly from school to a game store, and then from the game store to a skate park. So he's going from school to the game store to the skate park. The game store is 3 miles south of the school, and the skate park is 4 miles east of the game store. How far is the school from the skate park? So we know that the distance from the game store to the school, that was 3 miles, and from the game store to the skate park is 4 miles, and it also gives direction. So it says the school, we'll start there. The game store is 3 miles south, so that would be directly below. That's going to be 3 miles, and here's the game store. Then it says the skate park is 4 miles east. So this is 4. This is the skate park. And it wants to know this distance here. And because it's directly south and directly east, this is going to make a right angle. So we know that if we want the distance from the school to the skate park, we can set up the Pythagorean theorem because this is a right triangle. So I'm going to label this side A and this side B. That's going to be 3 squared plus 4 squared equals c squared. So 9 plus 16 is 25. When you square root both sides, we get that c equals 5. So the school is 5 miles from the skate park. Last example, how far from the base of a house do you need to place a 15-foot ladder so that it exactly reaches the top of a 12-foot wall? So here we have a house. And I'm just going to show a part of the house. This is the side of the house. Here's a window. This is our roof. There. So we need to put a ladder that's 15 feet. So we have a 15-foot ladder. It's a 12-foot wall. And we want to know how far from the base of the house. There's the base of the house. The base of the house and the ground is a right angle. And we need to know this distance here. So again, it is Pythagorean theorem, but this time we actually know the hypotenuse. We don't know one of the legs. So again, I'm going to label this one A, and we'll call this one B. So 12 squared plus B squared equals 15 squared. That's 144 plus B squared equals 225. We do 225 minus 144. We get 81. Square root both sides, and we find that B is 9. So the ladder should be placed, or the ladder will be 9 feet from the base of the house. So the biggest thing with these application-based problems is that you want to make sure you are drawing a picture, because drawing a picture will help you see that right triangle right away and get things labeled. In class, we will work on worksheet 9-2.